Hey guys, I miss you. It's so weird being in here trying to teach lessons on chapter 15 without your faces in front of me. And I'm literally looking at your empty seats right now and I'm seeing you, but I'm not. I swear I'm not hallucinating. I'm just being me. I hope you guys are good. I hope everybody in your family's good. This is so weird. But here we go. So we're going to do a series of videos. My goal is to keep them 10 minutes or less and try to kind of get the content and the topics to flow decently. It's awkward, I know it is. As you guys need help and have questions for me, we'll figure this out. If we screw things up, we'll fix it and then we'll try it again. But I've been whipping out videos for pre-calculus and hopefully everything I'm doing has been working well. So here come your videos for AP Stats. We have one section in chapter 15. And once we get cruising through it, I think we can do this in about 3 videos. I'm hoping like 3 10 to 12 minute videos. I'll try to cut myself off at a good spot at about 10 minutes each. Chapter 15 is kind of a combination of chapter 3, which was linear regression, and everything we've done with confidence intervals and significance tests. And you're going to notice my volume changes because I never know if I'm talking loud enough or quiet enough because my room is empty and I feel like a radio host and I'm talking to a microphone, but I don't know if you can hear me. So hopefully you can. Turn it up, put in headphones, rock out to me, whatever it is, because this is just so weird. So we're going to talk a little bit about the manatee data, which is all the way back in chapter 3 on page 179, because we're familiar with it. We get the context of it. And also there's a really great example that kind of carries through chapter 15 that starts on page 889. It's kind of funny. It talks about being able to predict a child's IQ from how much they cried as an infant when you snapped their feet with rubber bands. And you're like, what parent would do that? Well, 38 of them in this study, and it was legit. It's a little bit old. I think maybe some ethics have changed over the years. But that's a really great example on page 889 that carries you through the chapter. So if you need something more beyond my videos here, you can kind of read through that and pick and choose the things that you want to process. So we're going to jump right in. Remember that in our manatee data, X was powerboat registration in thousands, Y was manatee deaths. So we have our little formula of y hat equals A plus bx. Remember that A is our y-intercept, B is our slope. These are all sample statistics because we don't have the entire population of manatees and powerboat registration information available to us. We have our snapshot in time. And so when I say sample statistics, kind of like X bar and S and P hat, because they come from the sample. Well, the whole goal of those sample statistics is to be able to predict for population parameters. Well, those population parameters are mu sub y equals alpha plus beta. Beta has a long little tail on it, x. And if you're wondering what the beep is going on there, well, here's the thing. You know how x predicts mu and s predicts sigma and p hat predicts p? Well, A predicts alpha. Kind of shocking. Probably shouldn't have used green paper, but we'll see if this can work. And B, yeah, you can see that, predicts beta. And so then, I need another color. I'm going to have to use green on green. We'll see how this goes. Y hat, oh yeah, you can see that, predicts mu sub y. You're like, what the beep is mu sub y? Well, mu sub y is the collection of all possible samples. That's kind of cool. A collection of all possible samples of powerboat registration and manatees. So that's assuming that we've got everything we could ever know about these two quantitative variables. We don't have that. So our task is to predict it. So we're going to do a little bit of quick calculator review. Once you get your data in, and again, that's on page 179, powerboat registration in list 1, manatee data in list 2, my Inspire people, you might already still have this because I don't think you guys really ever delete your stuff, which is kind of nice for you. So pause me, type that in. Time to unpause me. Let's roll. So go to Stat, go to Calculate, go to number 8, lim reg a plus bx, L1, comma L2, comma var's function, y1, all that good stuff. You know what you're doing. Here we are. So I'm going to write this down. My problem is I keep forgetting to scoop my paper up, so this is my second time doing this video. Y hat equals a plus bx, which means y hat equals negative 41.4 plus 0.125x. If ever you are asked to estimate alpha, this is what you use to estimate alpha. A estimates alpha. If you are asked to estimate beta, B estimates beta. So if you're asked to do an estimate, alpha is approximately negative 41.4 because this is the only sample we have to use, thus it has to reasonably predict our population. If you are asked to predict mu sub y, it would be your equation because this is the best that we have. It's what we got. Like we use x bar to estimate mu, s to estimate sigma. We're going to move on with life. So saying that is now actually leading us into why are we looking at this? Our job is to figure out, and I move my paper, is there really a relationship between y and x? And this is kind of trying to take us down the path of, does x cause y? And I'm putting that in quote marks because to use the word cause really makes me nervous. It feels like I'm going to get sued. We don't do that in statistics, but we have to determine, do we have a leg to stand on here with really truly being able to say that we can correctly, reasonably predict the number of manatees dying with respect to powerboat registration? And to do that, we are going to focus on B. Remember, that's our slope, also known as beta with the long tail. So here's the deal. If B, aka beta, so I'm going to put B beta, if that's equal to 0, what you guys have is a flat line. There is no relationship between y and x. If we've got a flat line, then the scatter plot we've got going around it, the best thing that we can fit in there is a flat line. Boring. We aren't using these to talk about each other. They don't work well. Now if B, also known as beta, oops, hello whiteout. We must have bought the cheapest whiteout ever. Okay, if B, also known as beta, is greater than 0, what that's telling us is that our scatter plot has a positive relationship. That's kind of cool. That means that x can predict y in a positive manner. If beta, also known as B, is less than 0, then guess what, guys? We have a negative relationship. And so that's what we're going to be doing. Now I'm hoping this is kind of looking familiar to you because what we're going to be starting off with now is we are going to do significance tests and confidence intervals for beta, also known as B, also known as slope. That's kind of cool. So I'm going to pause on this first video. I'm going to title this the intro. And then my next video, I'm going to start addressing conditions and hypotheses and maybe calculations. I just don't know how long it's going to take. But I'm also almost at my 10-minute mark. So time to stop.